Hello, in this problem we are asked to find a third degree Taylor polynomial for this function f of x equals negative 3x plus 10 quantity to the 3/2 power centered at a equals 2. So in order to find the degree 3 Taylor polynomial, we're going to have to find 3 derivatives, right? And we're looking for the corresponding coefficients. So we'll start with the n equals 0 case, which is just the function itself, right? F of x is negative 3x plus 10 raised to the 3/2 power. And here we're going to substitute the center of the series for x, and we'll get f of 2 is equal to that negative 3 times 2 is negative 6 plus 10 is 4. So you get 4 to the 3/2 power, which is really 2 cubed, or 8, right? So C0, the 0th coefficient, is going to be 8 over 0 factorial, but 0 factorial is 1, so that's just 8. So now we'll proceed to the n equals 1 coefficient, and we'll have to take a derivative. The first derivative is going to be 3/2 times negative 3x plus 10 raised to the 1/2 power times negative 3 by virtue of the chain rule. We're multiplying them by the derivative of what's inside. And simplifying this a little bit, we'll get negative 9/2 times negative 3x plus 10 to the 1/2 power. And now we'll substitute in f prime of 2, excuse me. We'll substitute 2 in for x, and we'll get negative 9/2. And when you substitute 2 into here again, you get 4 to the 1/2 power, which is just 2. So you get negative 9/2 times 2, which gives us negative 9. So the n equals 1 coefficient is going to be this derivative divided by 1 factorial, which is just 1. So the n equals 1 coefficient is negative 9. Okay, let's proceed down to the n equals 2 case. The n equals 2 case is, well, we'll take a second derivative. So we'll get f double prime. And here we'll bring the 1/2 down, and you'll get negative 9/4 times negative 3x plus 10 to the negative 1/2 power multiplied by the derivative of what's inside again, which is negative 3. Simplifying this, we get 27/4 times negative 3x plus 10 to the negative 1/2 power. Now substituting in 2, the center of the series, we'll get 27/4, and this is going to be the square root of 1 over the square root of 4, which is 1 over 2. So we get 27 divided by 8 for the second derivative evaluated at 2. And so therefore the second coefficient is going to be 27/8 divided by 2 factorial, which is 27/8 over 2, which is 27/16. Okay. And finally, we'll get the third coefficient, and we'll have to take the derivative one more time. So for n equals 3, right, we'll find f triple prime. That's going to be negative 1/2 times 27/4. That's going to give us negative 27/8 times negative 3x plus 10 to the negative 3/2 power times negative 3. So f triple prime, if we simplify this a little bit, will be negative 81/8. Actually, positive 81/8 because you have 2 negatives. positive 81/8 times negative 3x plus 10 to the negative 3/2 power. Again, substituting in x equals 2 for the center, we get 81/8. This is going to be 1/2 to the 3/2 power. 1/2 to the 3rd power, excuse me, which gives us 81/8 times 1/8, which is 81/64. And now to construct the third, the n equals 3 coefficient, that's going to be 81/64 divided by 3 factorial, which is 6. That's a 3. So that's 81/64 times 1/6, which gives us 81/384, which reduces to 27/128. Okay, so now we have everything we need to construct the 3rd degree Taylor polynomial. The 3rd degree Taylor polynomial for this function will start out with the constant term, the first C0 that we found, which was 8, right? Then it's going to be minus the second coefficient is 9 times x minus 2, then plus 27/16 times x minus 2 squared, and then finally this third coefficient plus 27/128 times x minus 2 cubed. And there you have it. That's the 3rd degree Taylor polynomial for the function.